Lesson 7-4, Geometric Sequences. A sequence is a set of numbers in a particular order or pattern. Each number in a sequence is called a term. So the first term is denoted by a subscript 1, the second term is a subscript 2, and so on. There are different kinds of sequences. We have finite sequences, which means they come to an end, or you have infinite sequences, which means they continue on forever. A sequence can also be defined as a function. So a sequence is a function in which the domain consists of natural numbers, so 0 or 1, 2, 3, 4, not 0. And the range consists of real numbers. So you have a subscript n, or a subscript 1, a subscript 2, and so on. So the domain is always the position. So you get the first term, second term, third term. And the range is what is the term in each of those positions. One of the sequences we're focusing on today is geometric sequence. For a geometric sequence, each term is determined by multiplying a non-zero constant by the previous term. We call that the common ratio. The nth term of a geometric sequence, you can find that the nth term n of a geometric sequence is the first term is a subscript n, and the common ratio is r. You can find these by using, or find the sequence by the formula a subscript n times a subscript 1 times r raised to the n minus 1 power, where n is a natural number. So we have explicit formulas, which I just stated. You use that to find any term of a sequence. So if you're going to find the fifth term, you're going to use the explicit formula. If you want to create a sequence, then you would use the recursive formula, which would be a subscript n equals r times the previous term. That's what the a subscript n minus 1 means in this formula. So a geometric means are the terms between two non-consecutive terms of a geometric sequence. And we'll get to geometric means later in this lesson. So first we want to find and graph the first six terms. But before that, we need to go through our first example. So determine whether a sequence is geometric or not. For it to be a geometric sequence, it has to have a common ratio. So I take one term divided by the previous one. That gives me 3. If I do 15 divided by 6, that gives me 5 halves. They're not the same, so no, this one is not a geometric sequence. This next one, if I do -1 divided by 1, gives me -1. Then 1 divided by -1 gives me -1. And -1 divided by 1 also gives me -1. So yes, this is a geometric sequence. The common ratio would be -1. This next one, 1/4 divided by 1/2, which really means I'm multiplying by 2. This will give me 1/2. And if I take 1/6 divided by 1/4, which really means I'm multiplying by 4, this gives me 2/3. They're not the same, so no, that's not they're not a geometric sequence. Now we go to example 2, where we find and graph the first 6 terms of the geometric sequence. They give us the first 3. We need to first find the common ratio. If I take -2 divided by -1, it gives me a +2. So I'm multiplying by 2 every time. So this will give us -8, or multiply by a +2, so it gives me -8, -16, and -32. There are my 6 terms, or my first 6 terms, and the ordered pairs, the domain would be my x, or my position. So we have 1, 2, 3, 4, 5, and 6. Those are the positions, and the range is what's the term number. So we have -1, -2, -4, -16, or -8, -16, and -32. So to plot those on a coordinate plane, we just match the domain with the range. So 1, -1 would be here. 2, -2 would be roughly here. 3, -4. 4, -8. 5, -16. And 6, -32. If I do not draw a line because this is a sequence. There's no numbers in between as part of the sequence. Next, find and graph the first 7 terms of this sequence. So for this one, I take 3.2 divided by 1.6 and I get 2. So I'm multiplying by 2 every time. So 6.4 times 2 gives us 12.8 times 2 gives us 25.6. Next would be 51.2 and 102.4. So I have 1, 2, 3, 4, 5, 6, and 7. Those are my term positions. And the specific term numbers are 1.6, 3.2, 6.4, 12.8, 25.6, 51.2, and 102.4. Now to fit these on here, I'm going to count these by tens. And these, the terms, which be 1 through 7. Then we can plot them on here. So we got 1 and 1.6, 2 and 3.2, 3 and 6.4, 4 and 12.8, 5 and 25.6, 6 and 51.2, and then 7 and 102. So that would be what my graph will look like when we plot the first 7 terms of that geometric sequence. Example 3, find the nth term. Javier wants to eat less chocolate each day. To achieve this, he decides to start with a 50-gram bar of chocolate and eat half of it the first day, and half of what is left of the bar the second day, and half of that the third day, and so on. If Javier starts on a Monday, what is the mass of the piece that he will eat on Friday? So I'm going to use a subscript n equals a subscript 1 times r raised to the n minus 1 power. I need to find there are 5 days, so I'm going to put a 5 in for n, so 5 days from Monday to Friday, equals the first term. The first day he's eating, he eats from a 50-gram bar, so that's only 25. So he eats half of that, so that's 25. The common ratio, he's eating half of it. So that's 1/2 as my common ratio, raised to the 5 minus 1 power. So to put this on our calculator, we're going to have 25 times 0.5 raised to the 4th power, and that gives us 1.56, or if I put it to the nearest 10th, the 5th term or the 5th day would be 1.6 grams. Next, says Lauren puts $500 in a savings account, which each year yields 4% interest on the amount she currently has saved. If she starts the account just before she begins her 4-year college degree, how much will the account have when she graduates? Round to the nearest cent if necessary. So this is an interest problem. So I'm going to use A times P times 1 plus the rates raised to the T power, or in this case, it would be n minus 1 power. So the account balance, principal amount is $500. 1 plus the rate as a decimal is 0.04 raised to the n. So after the 4-year, when she graduates, so this was going to be the 5th term, so it would be 5 minus 1, because it's 4 years of college, so she starts it before her 4-year college, so it would be afterwards, so 5 years. If I put that in the calculator, I would get the 5th year, there would be and the nearest cents would be $585 or $84.93. Example 4, we're going to write an equation for the nth term of the sequence. So write an equation for the nth term of each geometric sequence here. So a couple things we need to find. So we want our answer to be a n times a subscript 1 raised to the n minus 1 power. So I need to find our first term. So our first term is 1, or negative 1. So I can do a subscript n equals a negative 1 times the common ratio. I'm going to take 3 divided by negative 1, which gives me negative 3. So my common ratio is negative 3, and then it would be n minus 1 power. So that would be my equation for that one. This next one, they're telling me the 8th term and what the common ratio is. But for me to write the equation, I need to find the first term. So to find the first term, we are going to use our formula, which we know that the 5th term, or a subscript 8 is 5. So that would be there. And then we're going to use, we need to find the a subscript 1. The common ratio, they tell us, is 1/2 raised to the n minus 1, which is 8 minus 1, because they told us it was 8. Now to simplify this, this will give us half to the 7th power. So 0.5 to the 7th power gives us 1 over 128. So we have 5 equals a subscript 1 times 1 over 128. To get a subscript 1 by itself, I multiply by 128 on both sides. And 128 times 5 gives us 640. So a subscript 1 is going to give us 640. So my formula would be a subscript n equals 640 times the common ratio of 1/2 raised to the n minus 1 power. Next, write the equation for these sequences. So to find the common ratio, we have 3 over 20 times 4, which will give us 3/5. So the common ratio is 3/5. Again, I want my equation to be in a subscript n equals a subscript 1 times r raised to n minus 1 power. So I have a subscript n. The first term is 1/4. Common ratio is 3/5 raised to the n minus 1 power. Next one, I'm given the third term, so that's 63 over 100 equals a subscript 1 times the common ratio of 3/10 raised to the 3 minus 1 power. So 3/10 squared would give us 9/100ths. So I have 63 over 100 equals a subscript 1 times 9 over 100. To get that by itself, multiply by the reciprocal, which will give us 7. So a subscript 1 is 7, so I have a subscript n equals 7 times common ratio of 3/10 raised to the n minus 1 power. Example 5, recursive and explicit formulas. So we're going to go back and forth from these. It says, given a formula for a geometric sequence in recursive or explicit form, translate it to the other form. So letter A, I have a subscript 1 equals 5 and a subscript n equals 1/5 times a subscript n minus 1. And n has to be greater than or equal to 2. That part where it says n is greater than or equal to 2, I'm not going to worry too much about that. We know the first term and we know the common ratio. So we are going to write this as a subscript n equals the first term, 5, times the common ratio of 1/5, and it would be n raised to the n minus 1 power. So that would be our explicit formula. Now B, we're given the explicit, we have to write it as the recursive formula. So to write it as a recursive formula, we need to know what A subscript 1 is, and we need to know what the common ratio would be. And then we can write our equation. So it has to look like letter A. So A subscript 1 is 2/3. It's always what's in front. So this is our A subscript 1. Here's our common ratio. Common ratio is 7. So now to write this, we would have A subscript n equals our first term, or our common ratio is 7 times A subscript n minus 1. So that would be our recursive formula. Next, here we need to write the explicit form. So this would be A subscript n equaling our first term 1/3 times the common ratio of -1/4 raised to the n minus 1 power. B in recursive form, first term is -2. The common ratio is 13/6. So we would have A subscript n equals our common ratio of 13/6 times A subscript n minus 1. And example 6, find geometric means. So find the first 4 geometric means between 243 and 32. So this is saying the first term is 243 and there are 4 terms in between. You gotta get to 32. So to find this, we need to know what the common ratio is going to be. We know that there are 6 terms here because we have the 2 that they gave us and the 4 in between. So there are 6 terms. So we can use that to help us. So the 6th term, so A subscript 6 is 32. If I do 32 equals the first term of 243 times the common ratio I don't know, but this would be 6 minus 1. And now I can simplify this, so I can divide this by 243 on both sides. And 32 divided by 243 gives us a larger decimal, which will give us 32 over 243. And this is going to equal r to the 5th. Now to undo r to the 5th, I'm going to find the 5th root of both sides. So on the calculator, we're going to do in parentheses 32 divided by 243. In parentheses, I'm going to raise this to the 1/5 power, which just means the 5th root. Hit enter and change that to a fraction, and we get 2/3. So the common ratio is 2/3. So now if I take my calculator and do 243 times 2 divided by 3, I get 162. Then if I multiply that by 2/3, I get 108. Then hit enter again, I get 72. Hit that again, and I get 48. And if I hit it once more, there's my 32. And that completes my functions sequence. So these are the 4 geometric means between the 2. And the last one, find the 3 geometric means between 1 and 256. So if A subscript 1, 2, 3, 4, 5 is 256. I can now do 256 equals first term 1 times the common ratio, I don't know, raised to the 5 minus 1 power. So it's going to give me 256 equals r to the fourth. Find the fourth root. The square root of 256 is 16, and the square root of 16 is 4, so this would be 4 as our common ratio. So that means I'm going to be multiplying by 4 each time, so this would be 4, 16. 16 times 4 is 64, and 64 times 4 is 256. So these are the three geometric means between 1 and 256. That is our lesson on geometric sequences.